Hello everyone. Today we are going to see one of the application of diode, that is sinusoidal input, and the circuit name is half wave rectification. So how to design half wave rectifier, that is what we are going to see. So here I'm going to draw the sinusoidal input. You see, one of the application of diode, that is half wave rectifier, that is going to convert this alternating current AC input, or you can say sinusoidal input, into direct current, or you can say DC current. So this is what our input is, where this vertical is voltage V input, this one is considered for time. This only one cycle is shown over here. So this is T by 2 and this total time period T. This one is small t. This highest peak, that is Vm, lowest one is minus Vm, and this is considered for one cycle only. V input, that is the sinusoidal input, and we can write this as Vi equal to Vm sine omega t. Okay, so this is our input signal. Now this input signal is going to provide to half wave rectifier circuit. Over here it is written half wave rectification. So actually this sinusoidal input can be developed using transformer even. We can use step down transformer. So here if I draw this circuit, these are the two primary winding side. Over here we can develop like this way. This is a transformer circuit, and this side is VAC, and at our household inputs this is a little bit higher values. And this side, this is a primary winding, and this side secondary winding, and that is considered lower turns, or you can say step down one. So here it will be lesser turns, so that is a step down. So at this point we will consider over here that our V input. So this V input is nothing but this one. Okay, so now we will develop a half wave rectifier circuit where this one is our input, and if I draw that circuit further, this is our diode. Diode will one of the key component to convert this AC signal to output DC1. So rectifiers are nothing but conversion of AC to DC. Those are used to convert the AC signal to DC. Now where we'll get that DC signal? That is across load resistance. So I'm drawing over here the load resistance. That terminal is this one. Over here resistance R, this diode considered as capital D. This is a plus terminal, this is a minus terminal, where we will get this our output signal. Now for this circuit, we'll consider step by step what will happen for the first half cycle. You can see over here for the first half cycle, and then after we will also check what will happen to second half cycle. Now let us check for the first half cycle, that is a positive half cycle, what will happen to the diode. So for the positive half cycle, here is a plus, here is a minus, and current direction will be this side. So you see, as we are aware that this is a positive P terminal and this is the negative N terminal, or you can say anode terminal diode, that is nothing but P, and cathode terminal of diode, that is nothing but N terminal. So here in our case, this P and N, over here some plus supply over here. So whenever for the ideal diode Vp minus Vn, this potential difference is greater than 0, this potential difference is greater than 0, the diode is in forward bias. You can say it will act as a closed switch. So now in this case, what will happen to the diode? As we know, here is a positive and the higher value, so this difference will be definitely going to get greater than 0. Here this diode we have considered is a ideal diode. So voltage drop Vd equal to 0. Voltage drop across this diode is 0. So now when this condition is approved, what will happen? This diode is act as a closed switch. This diode will act as a closed switch. So we can draw like this way. This will act as a closed switch. Now whenever this act as a closed switch, what we can do, over here at the output terminal, this side, our signal, if I draw the output signal, I can able to see that whatever input signal is there, the similar input signal will be available at the output side. So here our input signal reaches up to Vm, that half cycle we are considering for. Here also we will get the similar output V output up to T by 2 times. We will get the same signal up to T by 2 times. Output signal will be similar as the input signal, and that maximum is nothing but Vm peak. Now this is the first case when we are getting for the positive half cycle of this waveform. Similar positive half cycle we are getting at the output because this diode was short circuited. Now we will consider the second case. Now when we are considering the second case, what will happen for the negative half cycle? You can see over here for this one, for this part of the waveform, when we are consider the negative half cycle, the current polarity will different, plus over here, minus over here. Current will move like this way. During that negative half cycle, this is the plus terminal now. Now you see what is happening. If you compare this equation, Vp minus Vn, this condition will not going to fulfill, because what will happen in the second case, this is our first case for the positive half cycle, for positive half cycle. Now the second case, for negative half cycle. This is our second case. Vp minus Vn is less than 0 because here is a positive, here is a negative. So Vp minus Vn will be less than 0. So what will happen? Vp minus Vn is less than 0. So this diode will act as an open circuit. This diode is going to act as an open circuit, or you can say it will act as an open switch. So what will happen? The current, this current in the reverse bias will be equal to 0 because the loop is not going to complete. So diode D is in reverse bias. Because of that, during this half cycle, the diode will act as a open switch, and when it is acting as an open switch, our V output will be 0. So over here, for that instant of time up to time t, the output will remain 0. So this is what happening for the positive and negative half cycle. For negative half cycle, diode is open circuited. The diode is open circuited because of it is in reverse bias. Because of this condition, the current could not be able to flow, and that I equal to 0. Because I equal to 0, finally the output voltage across this R, the output voltage will become 0. So this is how we are getting the half cycle. The positive part of that half cycle is similar as it is we are getting input equal to output, but for the negative part is 0. Now if you draw this full, if we can draw that one, let me draw this one. If I draw the full output waveform with some more cycles, this is we have considered for the only positive half cycle. If I draw the similar compared with the other cycles, how, which kind of waveform we can able to measure, or which kind of waveform we can able to see, that is what I'm going to show you. This is one I'm drawing for the output. The first one I have drawn for the input signal. Now this is my input signal. This is sinusoidal input signal. This is just a one cycle. I'll continue with the second cycle as well, and let me draw a little bit part of one third cycle also. I'm going to cover that third cycle also. Now to observe the exact output, let me draw these lines for better understanding. So the time period I'm covering t by 2, then further timings. So actually I have drawn total 3 cycles. So this is our V input, this is t by 2, that is t, then you can go further, this is 3t by 2, that is 2t, that is this is actually 4t by 2, so we'll get 2t, then this is 5t by 2, this is 3t. Actually 3 cycles are there. So this is the time where this 0, that is amplitude axis, the y-axis, that is showing voltage, and this one we have considered for V output, and this is also time. Our V V input is nothing but Vm sine omega t. This is our highest peak Vm, and this is the lowest peak, that is minus Vm. We have considered our diode. Diode is ideal. So if I draw that circuit once again, this is just, I'm not going to draw that transformer part. Consider this side is the V input side. Here is our resistor. Here I'm going to draw that diode. So this is where the diode was connected, and this is where the resistor is connected. This is V input side, and this is our output. So this is R and this is D. Now positive half cycle, when positive half cycle for this instant of time, for this positive half cycle, diode is on, or you can say forward bias. So whatever V input equal to V output. So V input equal to V output. That is Vm. It is reaching up to Vm because we consider the diode is ideal diode. Now for the negative half cycle, diode is off. So at that time, this will be 0. This time, this output is 0. So here is some positive value we are getting, and this one is 0. So now the similar way, for another positive half, diode will once again become on and will get this signal. And when diode is off, the negative half cycle will get 0. And once again, if you go for the positive half cycle, we will get diode on and V input equal to V output. And over here, for the negative half cycle, V input equal to, actually V output equal to 0. So this is what, this kind of output waveform we are going to get for half wave rectifier, and this output is known as pulsating DC output. This condition we have taken for ideal diode. Now if you consider that diode is not ideal, what will happen? Suppose diode is considered as a silicon diode. So because of that diode is silicon diode, this zero point 0.7 consumption of diode will be there, and this one over here to this line, suppose it is a 0.7 line, reference line I have taken 0.7, this is 0.7, this is 0. This peak, this signal will start from here directly, and you will get the output peak will be Vm minus 0.7. So this will be our starting line if the diode is not an ideal diode. Okay, suppose this one is germanium diode, this line become 0.3 because germanium consumption, the threshold value is 0.3. Okay, so this signal will, for silicon one, this signal will like this way, you can draw like this way, and our this peak value will be Vm minus 0.7. equation of VDC, total conversion of VDC for the half wave rectification, it is VDC equal to 0.318 Vm. Remember this equation, VDC equal to 0.318 into Vm. This is for ideal diode, and for practical circuit conversion VDC equal to 0.318 into bracket Vm minus Vk. Vk is nothing but this one, knee voltage Vk. Okay, so maximum part of this half wave rectifier using diode, that is I have covered. I hope you understood this circuit in a better way. Okay, so I'm stopping over here for this video. We will cover the full wave rectifier